top of page 2 for 9.4, we're going to continue on now just with additional practice. Here now we've got examples where there's going to be some simplifying that can actually happen first and then rationalizing the denominator. So this is an example I referenced earlier where there's going to be some things you can do first to make it easier for yourself, especially dealing with smaller numbers as you rationalize. So I'm going to do this problem in 2 stages here. Across the first line, I'm going to do the simplifying part. Let's see if we can make this into a little bit simpler in terms of numbers that we're going to need to rationalize. It actually just, you don't have to do this part first. You could actually go straight to the rationalizing, radical 40 over radical 40, but it gives you bigger numbers to have to deal with later. So sometimes it helps to simplify first. Okay, so what does that mean? Let's just make equivalent statements here. We're going to split this, radical x over radical 40. X is not a perfect square. 40 is not a perfect square, but let's see if there's one inside of it. That radical x is just going to stay the same. But let's see what radical 40 can split into. Again, we're looking for, since it's not a perfect square, we're just looking for 2 numbers where when you multiply them you get 40, and one of those multipliers is a perfect square. So a good example would be 4 times 10. That gives you 40. 4 is a perfect square. Perfect square numbers. Sorry, that wasn't written very clearly. Let's try that again. Perfect square number. Abbreviated there, but you get the idea. Okay. Again, you still have radical x on the top, and some of you will get to the point where you can do all this in your head. I'm just going to write out every step so you can really see what's happening. Just like we can mush things together, that's not the technical term, but you can combine radicals. When you're multiplying, you can combine what's underneath the radical sign together. You can also split them apart. So this can be split into 2 radicals, radical 4 and radical 10. And again, this radical x is just staying up here the whole time. I'm not doing anything with it. But that radical 4 we know to be 2. So what we've done here is we've taken the radical x over 40 and created as simple of a denominator as possible to decrease what we have to rationalize by. Just helps with the simplification later. Okay, so now we are ready to rationalize. So I'm going to rewrite that part down here. We're starting with the radical x over 2 radical 10. And again, I'm writing out every single piece here so you can see what's truly happening. When you do the assignment, you'll get into a rhythm and a flow where you may not have to show as much work. You can do a lot of this in your head. So when we rationalize, the goal here is to get rid of the radicals in the denominators. So the piece that's in our way right now is this radical 10. Totally fine to have a plain old 2 on the bottom. It's the radical 10 that's the problem, because that is not a nice whole number. So we're going to multiply by the issue. The issue here is radical 10. So we multiply same thing top and bottom because we're really just multiplying by 1. So when you multiply by 1, it doesn't change the value. We're just manipulating the look here. Okay. And then what we get is on the top, we're going to get radical x times radical 10. And you could go ahead and combine that in one step. I'll just continue on here on the top. You go ahead and combine that into radical 10x on the top. Is there anything that you can split 10 into that would then simplify? No, so this is just going to stay like this, radical 10x. Let's see what happens on the bottom here. You still have the 2, so that's still there. 2 stays there the whole time. You've got a radical 10 times a radical 10. Again, you can mush those together here. Underneath the one radical, 10 times 10. Continuing on, you've still got the 2, but what you have underneath is a radical 100, because that's what 10 times 10 is. And this is, you intended this to happen. It shouldn't shock you, because what you were trying to do was create a perfect square that would simplify to, when you took the radical, it would simplify to a whole number. So getting a nice number like square root of 100 shouldn't surprise you at all. Again, the top stays the same, radical 10x, and on the bottom we still have our 2 that we've had the whole time. We didn't try to rationalize the 2. It's just fine. It's already rational. That's why it's called rationalize. You're trying to make this into a rational number that has a measurable denominator. But then the radical 100 is just 10 times 10, or 10 squared. So what you're looking at here is just plain old 10. The square root undoes the exponent of 2. So you're just multiplying now the bottom by 10. And as a result, your final piece looks like on the top, radical 10x, on the bottom, 2 times 10, which is just 20. And again, tempting to think, oh, 10 and 20, I can reduce that to 1/2. No, it's not 10, it's radical 10, and that is nowhere near the value of 10. So you can't start canceling. Canceling is a way to talk about how to divide out similar factors, and when you throw in a radical there, you're no longer dealing with just plain 10. You've got like 3 point something there, and it does not cancel like you're used to. So resist that temptation. Okay, that takes care of the top part of that. We'll move on. There's 3 examples here, so we'll move on to the bottom of the page in the next video.